This lesson is about proving a triangle is a right triangle. Our method is to calculate the distance of all three sides, then prove that the Pythagorean theorem is true. Or you can see if any pair of sides are opposite reciprocals of each other, forming a right angle. So getting started. The points are 0, 1, 3, 4, and 5, 2. I'm going to plot those. After I plot those points, I'm going to make a triangle with them. After I make a triangle, the first thing says you want to show that either a squared plus b squared equals c squared, or two sides are opposite reciprocals. It might be faster to find out whether or not two sides are opposite reciprocals, but to make a right triangle here, I can see that this side is 1, 2, 3. This side is 1, 2, 3. So this side is the square root of 3 squared plus 3 squared. That's a change in x. X is change in y. This far right is change in x. So this is the distance formula. The distance formula is derived from the Pythagorean theorem. It basically means that the distance from here to here is equal to the change in x squared plus change in y squared, square rooted. That's basically saying Pythagorean theorem. Like a squared plus b squared equals c squared. If you square root both sides, if you square root a squared plus b squared, you get square root of c squared. So c is the square root of a squared plus b squared. So in short, a squared is the change in either x or y, and b squared is change in either x or y. So that's what this distance formula comes from. It's derived from the Pythagorean theorem. We usually call it x2 take away x1 squared, and then y2 take away y1 squared, because that's how you get the distance from one x to the other. You take the x coordinate here and subtract backwards. Well, that's how they're related to each other. So I know that distance is square root of 3 squared plus 3 squared. In short, though, I know that rise over run is 3 over 3. The slope here. This is the only one that's probably going to be a right angle. And if it was, this rise over run has to be the reciprocal of 3 over 3, which is negative 3 over 3, or better yet, negative 1. 3 over 3 is 1. So you notice, from here to here, I go over 2, and then down 2. So the slope on this side is rise negative 2, run 2. That slope is negative 1. Let's take a look at this. If this slope is 1, its perpendicular slope should be the reciprocal of 1, which is also 1, with a negative sign on it. That's what it's supposed to be. That slope is negative 1. I know for a fact this is a right angle. Why? Because these sides have opposite reciprocal slopes. So I know that's true no matter what. So I prove that this is the right triangle because I can find that these two sides are have opposite reciprocal slopes. The person who created this worksheet expects you to use the Pythagorean theorem to prove that, and you could. You could find the length here and square it, and find the length there and square it, and find the length there and square it, and see if they're the same. But to prove the right triangle, truthfully, I would be looking for the slopes to see if anyone have slopes that have opposite reciprocal signs. That's all I'm going to do on that page. You can continue plugging in those values, but truthfully, you answered that question. So skipping ahead to the bottom, this triangle, triangle ABC, is a right triangle because two sides have opposite reciprocal slopes. Now prove that that's a right triangle without having to use Pythagorean theorem. Here's a new one. All right, the next one says, how do you prove is isosceles right triangle? So let's first plot these points. So I'm going to pause my video. You can go right ahead though if you have this printed out, or you can draw on your page and you can plot those points. You can start trying to decide whether or not it's isosceles. Remember, isosceles means has two equal sides. All right, so those are the points. We'll make a triangle with them. So now a triangle. And our job is to prove isosceles and right. So we want to show that two sides are congruent, and a pair of sides have opposite reciprocal slopes, or Pythagorean theorem holds true. Pythagorean theorem is true. Whichever one you want to use. All right, so let's get started. So we want to first prove two sides are congruent. If they're working with two sides congruent, I really can't tell whether or not be this pair or this pair. So I'm going to go ahead and start making right triangles. Decide which pair could be congruent to each other. So this length is 1, 2, 3, 4. This length is 1, 2, 3. That's a 3 by 4 triangle. I know it's a 3, 4, 5 right triangle. That's just a famous Pythagorean theorem, triple 3, 4, 5. So here, this side is 1, 2, 3, 1, 2, 3, 4. This side is 1, 2, 3. So it's also 3, 4, 5. So I know I got at least two sides congruent, and this side is 1, 2, 3, 4, 5, 6, 7 by 1. So this side is square root of 7 squared plus 1 squared. So I know it's at least isosceles. Now I want to prove that a pair of sides are either opposite reciprocals or Pythagorean theorem is true. So this side is, from this point to that one, I rise 4 and I run 3. So I rise 4 and I run to the right 3. That's a positive slope because I rose and I went to the right. From this point to the other, I go right 4, down 3. So my slope here is down 3, right 4. So if these are opposite reciprocals, then that's a right triangle. And 4/3 and 3/4 are definitely reciprocals. And one's positive, one's negative, so they are opposite reciprocals. So this is an isosceles right triangle. So I can prove that I know for certain that's true. So triangle ABC is an isosceles right triangle because two sides are perpendicular, or I might say opposite reciprocals, or have opposite reciprocal slopes. Just shorten it up and say perpendicular. And segment AC is congruent to segment CB. So AC is congruent to segment CB. So that proves that that's a isosceles triangle. All right, one last one. No, that's actually it. That's all I have. That's it. That's all I have. Good luck.